So let's look now at more with composition of functions that are inverse trigonometric functions and trigonometric functions. So as we look at this particular expression, you'll notice that sine inverse of 2/3 is not one of the angles that we know. 2/3 is not a ratio that is an output of a pi over 6 or pi over 4 or pi over 3 or a quadrantal angle that we know. So therefore, we have to come up with a new way to deal with this. So let's remember what this means. Let's start with arc sine of 2/3. This is an angle theta that yields 2/3 as an output for sine, but at the same time we know that theta has to be between negative pi over 2 and pi over 2. So if we sketch this angle, we know that sine of theta is positive within that interval, negative pi over 2 to pi over 2, only in the first quadrant. So there's our angle theta. So if we draw our triangle, dropping the perpendicular always to the x-axis, we know that sine of theta is 2/3. So we have 2/3. What is this particular side? Well, the length, using the Pythagorean theorem, will be 9 squared minus 2 squared will yield 5, then we must take the square root. And that is going to be a positive square root of 5 because we are on the positive x-axis. So now, let's look at the cosine of arc sine of 2/3. This is cosine of, now what's arc sine of 2/3? We said that was theta. So looking at our diagram, what is the cosine of theta? And it is root 5 over 3. So let's do something similar for this expression. So here we have the inside function is arc cosine of negative 7/25. So let's let arc cosine of negative 7/25 equal theta. This means that cosine of theta is negative 7/25, and we know that theta must be between 0 and pi. So if we sketch theta, this means that theta will have to be in the second quadrant. But now we can go ahead and drop a perpendicular to our x-axis, and adjacent and hypotenuse will be written. Hypotenuse is always positive, r is always positive. And now, what is this? The length is 7, but we'll go ahead and put a negative to denote the direction. And then opposite, by using the Pythagorean theorem, we know will be 24, and that should be positive 24. It's above the x-axis. Our y value is positive. So now, what's this yield for us? Cotangent of arc cosine of negative 7/25 is the cotangent of theta. Now, according to our diagram, cotangent of theta is adjacent over opposite. So negative 7/24. So this time we have a composition of trigonometric and inverse trigonometric functions that will result in an algebraic expression that's written in terms of u. In other words, whenever we write our answer will only have u in it. No other angles or anything like that, just u. So let's start off with the inside. So because arc sine of u is going to output an angle, let's write out what that means. That means sine of theta will equal u, and we know that theta is between negative pi over 2 and pi over 2 inclusive. So, how do we relate sine of theta and cosine of theta? So, we are calling sine inverse of u theta. So I want to find cosine of theta. Well, we have a Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1. So sine of theta is u, so sine squared of theta will be u squared. So this means that cosine squared of theta is 1 minus u squared. This means if I take the square root of both sides, cosine of theta will equal positive or negative the square root of 1 minus u squared. But we know something about theta. Theta is either in the fourth quadrant or the first quadrant, and cosine of theta is positive there. So therefore, cosine of theta equals the non-negative square root of 1 minus u squared.